indices for human-computer interaction applications based on facial image sequences. So I'll be covering introduction, objective, motivation, the survey, experiment design, and computation of indices with results. So basically, what do we mean by interest? It is cognitive and affective motivational variable for subjective experience of learning and other critical tasks. And interest level is generally influenced by emotion. So emotion modulates the selectivity of attention as well as motivational action and behavior. So main application of this is we need to know how human subjects are interested in, let's say, suppose we have a video. The subjects are watching a video. We need to know how interested they are in that. So that is basically measured with these indices which have been computed. So these are additional indices which have been computed besides the already existing ones. So manifestations of interest basically depend on how expressive the individuals are, then their drowsiness and responsiveness to the nearby distractions. So what is the objective? Formulation and implementation of interest indices from face image sequences. So this would be basically unobtrusive thing where we are actually monitoring without the subject being known. It is not knowing that we are monitoring it. So psychological aspects are more prominently manifested in face, and movie ratings are presently obtained from user feedback, but they may be biased because like there is possibility that a person, let's say two friends are going, then one friend has rated this, then this person would ask that and would rate that. So that's the cause of bias. The other thing is manual feedback of students through video courses is not authentic always. So which are the existing indices? First is Engaged Learning Index, that is a subjective score to capture 12 psychological components in the assessment of a student's engagement in the learning process. Next is Junior Index of Motivation, based on subjective feedback to evaluate the motivation of learning of school students. The third one is EEG based marker, which is indices for alertness, cognition and memory developed using psychological markers. So these are some of the existing indices. Next is per close, which is percentage of eyelid closure. So that is basically used for drowsiness analysis for drivers. And next we have pupil dilation based indices, requires expensive hardware for the purpose of eye tracking, and it may be harmful to the user, the infrared radiations. So which are the facial markers? Facial markers would be facial expressions. Then we have ocular dynamics, which is based on our eyes and our head pose. And advantages of development of indices from face images. So psychological aspects more prominently manifest in face, and monitoring the face using a webcam is convenient. So this is the experimental design. The experiment was performed on 100 undergraduate students from age group 18 to 22. The subjects were asked to watch videos and read the articles. So the response was recorded by the use of a webcam, and the tasks were, first were the videos on linear algebra, which most of them find boring, which were of 15 minutes. The second was popular web series, which is definitely interesting for all. And the third one is news-based web content of BBC Live. So we have layout of indices formation. So basically, uh, deep, new, deep convolutional neural network has been used for face detection over here, and the model used for eye detection as well as head pose. So that was modified according to the requirement. So three indices basically have been computed over here. First is ocular index, where eyes of the subjects are the main focus. So that is given by EO upon EO plus EC, where EC is the total frame count for closed eyes and EO is the total frame count for open eyes. Expression index, which is given by FP plus FO upon FP plus FO plus FN. So what is FP? That is the frame count for positive facial expression. FN is going to be for neutral facial expression, and FN is for, sorry, FO is for neutral and FN is for negative facial expression. So like we know that if the subject is not interested, then it's definitely going to be negative. And the third one is head pose index. The interest of an individual is best known if she is engrossed in listening to the lecture. So like we have head pose index for the same, which is given by HF upon HF plus HN. FP, I'm sorry, so okay, so HF is going to be for frontal, where the subject is looking into the camera directly, and HN is going to be non-frontal, where the subject is not interested, so is looking somewhere else. And these are the results. So these histograms, basically these three histograms indicate each of the three indices which have been computed. So OI, so what basically these suggest is the range. This range is mainly from 0.4 to 1. So 1 is going to be the highest interest, like the subject is extremely interested in that, and 0 will be exactly opposite. And the graph which is shown over here, so this one, so it is basically the it's the comparison with the subjective scores. So these subjective scores, SS1, SS2 and SS3 are the subjective scores for each of the indices, and they have been computed by taking feedback, manual feedback from the subjects. And EI, OI and HPI, so those are the indices which have been computed. And as it can be seen that it very well aligns with the subjective scores. So these are the three indices which were used, and the proposed indices may be obtained unobtrusively, as I said, that the subject does not know that we are monitoring, and it offers lower computational complexity than the previous indices which have been used, and the indices can significant in a number of applications like online evaluation of examinations, or if we want to evaluate how interested a particular subject is in any of the lectures or reading articles.